Good morning, students. Myself Kaushik Chakraborty. Today's our topic is D flip-flop. D flip-flop full name is delay flip-flop. This is the circuit diagram of the D flip-flop. Here we use four NAND gates: 1, 2, 3, 4. This is the clock pulse. It is always 1. This terminal and this terminal is connected to the NOT gate. This is the two output Qn plus 1 and Qn plus 1 bar. This is the previous output 0 slash 1, 1 slash 0. This is the truth table. Clock T and Qn plus 1. Clock is always 1, that's why 1 1. D is the single input, that's why 0 and 1. Qn plus 1 is the output. At first, we put the value is 0. This terminal value is 0. This terminal value is 1. 0 and 1. This NAND gate output is 1. 1 and 1. This NAND gate output is 1. So, this terminal value in this moment is 0. This terminal value in this moment is 1. So, 1, 1, 0, 0, 1, 1 means this value is satisfied. Again, we change the value. This terminal value is 1. This terminal value is 0. This time, this value is not satisfied. That's why Qn plus 1 output is 0. Again, D value is 1. Means this terminal value is 1. This terminal value 0, 1, 1, 0, 1, 0, 1. This terminal value is 0. This terminal value is 1. 0, 1, 1 means this value is not satisfied. This time we change the value 1, 0. This time this value is satisfied. That's why Qn plus 1 value is 1. Next is excitation table. Qn plus 1 D. Qn and Qn plus 1 two variable means 4 combinations 0 0 0 1 1 0 1 1. At first Qn plus 1 means present output value is 0. Go to the truth table. This time D value is also 0. That's why we put the value 0. Qn plus 1 value is 1. This time D value is 1. That's why we put the value is 1. Similarly, 1 0 is 0, 1 1 is 1. Next is characteristics table. Qn, D, Qn plus 1. This time Qn and D is the variable. There is that 4 combinations 0 0, 0 1, 1 0, 1 1. D value is 0. That's why Qn plus 1 value is also 0. D value is 1. That's why Qn plus 1 value is also 1. Similarly, 1 0 is 0, 1 1 is 1. This is the K-map of D flip-flop. This is a two variable K-map. This is the combinations of 2 1 and this is the equation of D flip-flop. Qn plus 1 equal to D. Next topic is T flip-flop. T flip-flop means trigger flip-flop or toggle flip-flop. Here, this is the circuit diagram. Here we use 4 NAND gate 1, 2, 3, 4. 1 clock pulse, it is always 1. This is the feedback path. This is also a feedback path. It is connected to NAND gate. This is the two output Qn plus 1, Qn plus 1 bar. This is the previous output value 0 slash 1, 1 slash 0. This is the truth table. Clock T and Qn plus 1. Clock is always 1, that's why 1 1. T is the single input, that is 0 and 1. Qn plus 1 is the present output value. T, at first T value is 0. We put the value is 0. Okay, this time clock is 1. This terminal value is 0. This terminal value in this moment is 1. This time we satisfied the previous output. That's why Qn plus 1 value is Qn. When t value is 1, means here t value is 1, clock is also 1, this is 0, this is 1. This time previous output value is complement. That's why Qn plus 1 equal to Qn bar. Next is excitation table. Qn, Qn plus 1, T. This is the two variable. That's why four combinations 0, 0, 0, 1, 1, 0, 1, 1. Qn plus 1 is present output. Qn is previous output. At first, Qn plus 1 equal to 0. This time, Qn value is also 0, means same. That's why t value is 0. Qn plus 1 value is 1. This time Qn value is complement. That's why we go to the truth table. This time t value is 1. That's why t value is 1. Qn plus 1 value is 0. This time previous output value is 1, means again complement. Go to the truth table, again complement. This time t value is 1. That's why this t value is 1. Qn plus 1 value is 1, means this time previous value is also n, means same value. That's why this time t value is 0. That's why this is 0. Next is characteristics table. Qn, t, Qn plus 1. This time Qn and t is the two variable. There's four combinations 0, 0, 0, 1, 1, 0, 1, 1. When the t value is 0 and the previous value is also 0, this time Qn plus 1 equal to 0. T value is 1, this time previous value is the complement. That's why Qn plus 1 value is 1. T value is 0, this time the previous value is 1, it is also a complement. That's why Qn plus 1 value is 1. T value is 1, this time Qn value is also 1, it is same. That's why Qn plus 1 value is also same. This is the K-map of T flip-flop. This is the two variable of K-map. This is the single combinations of 1, and this is the equations Qn plus 1 equal to Qn T bar plus Qn bar T. Next topic is latch. So at first, what is latch? The latch is a circuit that has two stable state and can be used to store the state information. A label sensitive flip-flop is called latch. Next is difference between latch and flip-flop. The difference between latch and flip-flop is that the latch is a synchronous that output can change. The latch is a asynchronous that output can change as soon as the input do. A flip-flop is a synchronous, on the other hand, is edge trigger and only change the state when the control signal goes from high to low and low to high. Next is SR latch using NOR gate. This is the circuit diagram of the SR latch. S means set, R means reset, means set, reset, latch. Here we use two NOR gate, 1 and 2. This is the two output Qn plus 1, Qn plus 1 bar. This is the previous output 0 slash 1, 1 slash 0. This is the truth table. SR two inputs means four combinations 0, 0, 0, 1, 1, 0, 1, 1. This is the output Qn plus 1 and Qn plus 1 bar. This is the action. When the SR value is 0, 0, means this value 0 and 0. This time this value is 0, this value is 1. This time the previous output is satisfied. That's why qn plus 1 value is qn and qn plus 1 bar value is qn bar. Means action is no change. When the value is 0, 1 means s value is 0, r value is 1. This time the output is 0, 1 means reset. Similarly 1, 0, this time value is 1, 0 set, and 1, 1 is cross cross means invalid. Next is excitation table. qn plus 1 srr. qn and qn plus 1, these two variables means 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. At first we saw that qn plus 1 value is 0. Go to the truth table. Where is the 0? This is 0. This time SR value 0, 1. This time the previous value is also 0. Means previous value means here is 0. So S value 0, 0. So that's why 0. R value 0, 1 means toggle. That's why D. 0, 1. qn plus 1 value 1. This time 1. 1. This time value is 1, 0. That's why we put the value 1, 0. qn plus 1 value 0. This time this 0. This time SR value 0, 1. 0, 1. Again qn plus 1 value 1. This time 1. Similar same value is 1 means here 1. S value 0, 1. That's why you put the value is D. R value 0, 0. That's why you put the value is 0. Next is characteristics table. qn, S, R, qn plus 1. There's a 3 input means 0 to 7 combination. 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. At first, we saw the S and R value 0 and 0. This time, qn value 0. That's why qn plus 1 is 0. S, R value 0, 1. This time, qn plus 1 value is 0. 1, 0. The value is 1, 0. The value is 1. 1, 1. This time qn plus 1 value is invalid cross. 0, 0. This time qn plus 1 value similarly 1. 1, 0, 1 similarly 0. 1, 1, 0 similarly 1. 1, 1, 1 similarly cross. This is the K map of the SR latch. This is the 3 variable K map. We put the value to this characteristics table. This is the 2 combinations, 1 and this is also another combination, and the equation is qn r bar plus s r bar. Next topic is SR latch using NAND gate. This is similar thing, but we here use only NAND gate. So that's why the truth table is changed. This time 0, 0 means invalid. 0, 1 is 1, 0. 1, 0 is 0, 1 and 1, 1 is qn and qn bar means invalid, set, reset, no change. This is excitation table is type similar. This is characteristic is also similar. This is the K map.